All right, so what we're going to do is we're going to practice do some examples with the quotient rule. We just finished developing the quotient rule. We just proved it from the product rule that we know, and we just fed that through and isolated for the derivative of the original function, and this is what we got. So the quotient rule. Now, if we were to take the derivative, right, let's find f prime of x here, and these expressions are the same. They're the same values. They're the same things. They're just written a different way. So we could use the power rule here. Pretty easy, right? That's going to be what? 12 times 5 is 60, x to the 4. So that's the easiest way to find the derivative here. I guess the product rule is the other one that we didn't do, but we could write this as a product. We could do 3x squared times 4x cubed, right? And the product rule, which we've also learned and mastered by now, would be this. So we could go the derivative of the first, that's 6x, times the second, plus the first times the derivative of the second, 12x squared. So that is 24x to the fourth plus 36x to the fourth. Let's see, 24 plus 36 is 60x to the fourth. Okay, so product rule works, power rule works. Let's see if quotient rule works. I'm going to actually, you know what, now I'm going to give myself some more room. Let me just bring this out of here. Let's make some more room down here. So I don't have the quotient rule now on the same screen, but let me just draw it real quickly here so we remember it. If f of x equals, I'm going to do this, g of x over h of x, then f prime of x is the derivative of the top times the bottom minus the top times the derivative of the bottom, whoops, h prime of x, what is that? All over the bottom squared. So h of x squared, hx squared. Okay? So that is the quotient rule. So let's use that quotient rule. And we'll do that here. So f prime of x here, the derivative of the top. Okay, 7 times 36. So it's going to be 210, 252. 252 x to the 6. Derivative of the top times the bottom, 3x squared. We're going to get into some big numbers here, but that's okay. Minus the top, 36x to the 7, times the derivative of the bottom, which is 6x. Okay, we good there? Divided by the square of the bottom function, so that's going to be 9x to the 4th. Okay, so right away the quotient rule is not the handiest, not the most efficient, all right? There's some bigger numbers, some more operations, but sometimes we can't get around that, right? Sometimes you can't just write it as a polynomial or a product, and so you got to do it this way. So this actually is the easiest way in a lot of circumstances. Okay, so what's 252 times 3? What's that? 6, 7, 7, 50, what is it? 7, thank you, 5, 6, x to the 8, minus 36 times 6 is 180, 216, 216, x to the 8 over 9, x to the 4. Okay, well, that's nice. We have like terms up top, so that's really good. So let's combine those. 756 minus 216 is 540. X to the 8 over 9, x to the 4. And so what's 540 divided by 9?
60.
That's going to be 60. What's x to the 8 divided by x to the 4? X to the 4. Okay? So it does work. This one is a bit of a longer stretch here, but that's an example of the quotient rule working. Now let's get to our textbook. All right, let's get to our textbook. And, let's do something like... something that looks really ugly. Do you want to do an example, or do you want to do one of the questions from your assignment? The examples, you know what, they're right there. How about we just not do those? Why don't we do something from your assignment, okay? Okay, cool? Can you say cool? Are we cool? Okay, so let's do one of these two. It's always fun when the teacher does your homework for you, right? I mean, I think that's always great.
Yeah, best work.
Okay. You.
More B forward.
Yeah. All right, so let's do A, f prime of x. The quotient rule is the derivative of the top. What's the derivative of the top? The top is x minus 1. The derivative is 1. Right. Derivative of the top times the bottom. Minus, now you got to be careful here, this is going to be a number of terms, right? So make sure you put a big bracket or a square bracket or whatever around this. So it's going to be the top times the derivative of the bottom. All over the bottom squared. Now here's a little hint. Okay, your first little shortcut hint. Do not, okay, I repeat, do not expand the bottom all the time. You may have to expand it later, but most of the time you may have a common factor up top, and you might be able to just eliminate by dividing those factors out. So just don't expand it out. Keep the factors on the bottom. That's just a hint, okay? All right, so what do we have? We have x plus 1 minus x minus 1, really, right? Oops. So that's going to equal, well, we have x minus x. And we have 1 minus a negative 1. So the x's are gone. And 1 minus negative 1 is, of course, 2. Right? 2 over x plus 1 all squared. And that's about as simple as you can get. That should be your answer, I think. Okay? Can't divide anything out. Can't simplify anything. It's okay to leave it as a quotient. The powers are positive, right? There are no negative exponents, so should be good. Does that look good to you guys? Does that look right? Okay. Shall we do B? Let's do B. Do B or not do B? What do you want to do? Do B. Do B. Derivative of the top is 2 times the bottom minus the top times the derivative of the bottom. Now I'm just ripping through this, but I should be making you guys do this, of course. All over the bottom squared. And again, just square it. Don't expand it out on the bottom yet, because you never know. You might be able to simplify in a step or two. Okay, so what do we got here? We've got 2x squared plus 2. Now, I would suggest taking this I mean, you can do all this in one step if you want, do some of it in your head. But we're going to have 4x squared. You're going to be subtracting a 4x squared. Okay, so I'll do that in my head. Subtract a 4x squared. You've also got a negative 2x that you're subtracting. So plus 2x. Does that look good? Yeah. If you want to do this multiplication first and just do it separately, I would strongly encourage that. So you don't do too much in your head and get it wrong. But if we gather like terms, what does this do for us? Well, I've got some x squareds. It's negative 2x squared plus 2x plus 2 over x squared plus 1 squared. And I can take a 2 out of here for sure to simplify that further. And can I just take it out and get rid of it? Not really. You got to leave it as a factor. And you might want to take a negative out even. I don't know. X squared minus x minus 1 over x squared plus 1 all squared. So I think that looks right. Can you factor the top? Well, don't think so. Can't factor the top, and even if you could, you're not going to be able to get rid of divide out a factor from the top and bottom. So someone might want to check that to make sure that looks correct. What does the back of the book say? The back of the book may, again, have their answers slightly in a different, written in a different manner. So
they didn't take the 2 out, but other than that.
They didn't take the 2 out, so they stopped up here. Yeah. So just be aware the back of the book may or may not simplify as far as you, or they may simplify further than you.
Do you
So,
want us to simplify?
well, we should simplify as much as you can. Any common factors you should divide out. Any like terms you should obviously combine. Usually, if there's negative exponents, you should write them as positive exponents. Stuff like that. That's kind of your guideline. Okay, so some examples for quotient rule. Questions?